Alright, this is lesson 6.1, the introduction video to expressions. First off, an algebraic expression is an expression that contains at least one variable. A variable, of course, is a letter to represent an unknown number. And so here in these first couple examples, we're going to look at simplifying an expression. We want the expression to be in simplest form. Okay, so in number 1 we have 2 times the expression x minus 6. And as you can see, as I read that, I said 2 times x minus 6 because I have a number, in this case 2, right next to an expression in parentheses. That is understood to be multiplication. And so what I can do here is use what's called the distributive property. And on your paper, I want you to draw a little arrow right here and write distributive property. Okay, we're going to use the distributive property to simplify the expression. You can use the distributive property whenever you have a number written right next to an expression in parentheses. And to show the distributive property, we're going to use what's called the rainbow. So I'm going to go 2 rainbow x, and that's understood to be multiplication. So I have 2 times x, which is 2x. Then I have 2 rainbow. Now this number right here is not 6. This is highly important. This number is not 6. You have got to consider the sign in front of the number, which is a minus sign. And so that subtraction sign is, yes, subtraction, but it is also a negative sign. So this is not 2 times 6, this is 2 times negative 6. And we know 2 times negative 6 is negative 12, right? And so the expression 2 times x minus 6 is, in simplest form, 2x minus 12. And so if we ask ourselves, what's the variable? Well, the variable is x, right? That unknown number. What number did we distribute? We distributed the number 2 to both terms inside the parentheses. Whenever you distribute, you only distribute to the numbers or to the terms inside the parentheses. So we distributed the number 2. Now, in this simplified expression, 2x minus 12, what is the coefficient? The coefficient is the number being multiplied by the variable, or the number in front of the variable. In that case, that would be the number 2. 2 is, in this expression, the coefficient. It's the number being multiplied by the variable. What if we ask ourselves, what is the constant? In this expression, 2x minus 12, what is the constant? A constant is a number that has no variable. In this case, the constant is not 12. It looks like it may be, but again, we have to consider the sign in front of the number. The sign in front of the term always goes with the term. That sign in front of the term tells you whether this is negative or positive, if there was a plus sign. And so always look at the sign in front of the term, because that sign tells you whether that term is positive or negative. In this case, it's negative, and so the constant is negative 12. The constant is negative 12. Okay, let's look at this next example. We have negative 4 times negative x, negative 3x minus 5. So I have a number written right next to parentheses. I know this is multiplication, and I can use the distributive property to simplify the expression. So I'm going to use the rainbow, negative 4 times negative 3x. Well, this is a negative times a negative, so they have same signs. I know it's going to be positive something. When 4 times 3 is 12, and I keep that x variable in my term. So negative 4 times negative 3x is 12x. And then I have, not only does negative 4 get multiplied by this term, it also gets multiplied by this term, right? Because you distribute to all the terms inside the parentheses. What is negative 4 rainbow, not 5, negative 5. So I have negative 4 times negative 5. Again, I know a negative times negative is a positive, so I'm going to put a plus sign or a positive sign. Negative 4 times negative 5 is positive 20. So that is my simplified expression. Now, can I add these things together? Can I add 12x and 20 together? Well, no, right? They're not like terms, because this has an x in it. That does not have an x in it. So I cannot add these together and say it's like 32 or 32x. No. I can't do that. This is simplest form. These are not like terms. So 12x plus 20 is my simplified expression. So the variable would be x, right? That's the unknown number, the unknown variable. What number are you distributing? You distributed a negative 4. You didn't distribute 4. You distributed a negative 4. What is the coefficient? What number is being multiplied by the variable? That number would be 12, right? It's being multiplied by x. 12x means 12 times x. What is the constant in this expression? Well, the constant has no variable. The constant in this case would be 20, right? Positive 20, because there's a plus sign. So the constant is 20. Let's look at our next one. In number 3 here, I'm going to not only have to distribute, but then I'll have to combine like terms in order to simplify the expression. And so here I see parentheses, and to eliminate the parentheses, to get rid of the parentheses, I always distribute. To eliminate the parentheses, you distribute the number in front of the parentheses. In this case, 4. So I'm going to need to distribute 4. Now, what do I do with this 12y term? Do I distribute it? No. I just bring it down. I bring it down here. So I'm just going to copy it down here. I'm going to distribute, show the rainbow from 4 to 3. That rainbow is understood to be multiplication. So 4 times 3, that is positive 12. That's why I put a plus sign there, because again, that plus sign is a positive sign. So 4 times 3 is positive 12. But I also distribute to this term because it's inside the parentheses. So what's 4 times 2y? That is positive, so put a plus sign, positive. 4 times 2y is 8y. Okay, don't forget your variable. Now, do I distribute the 4 to this negative 10 outside the parentheses? No. It's outside the parentheses. So it does not get distributed to, you just bring it down. So minus 10, right? Because it's a negative 10, because that minus sign tells me it's negative. So now that I've eliminated the parentheses by distributing, I need to combine like terms. Now, what are like terms? Well, on your paper, it says like terms have the same what? The same variable. They have the same variable, which means they have the same letter. But they must also have not only the same variable, they must have the same exponent. Same variable, same exponent. That's what it takes to be a like term. Those are the two criteria. Same variable, same exponent. Now you may say, Mr. Rope, I don't see any exponents in this expression. Well, they're there, right? Because they're invisible. They're there, but they're invisible. Look at the variable y. What is the exponent? Y to the what power? Well, if you don't see the exponent, it is understood to be 1. It's understood to be 1. And so we could say these are y to the first terms. But when the exponent's 1, it's understood to be there. In a math, we don't write it. Okay? And so these are y to the first terms. And when we have like terms, when you combine like terms, you add, that's your blank. You add the coefficients. And you keep the variable and the exponent the same. And so here if I ask, what are my like terms? Well, my like terms would be 12y. I'm going to put it in the same shape. I'm going to start off using boxes. So I have 12y and positive 8y. Do you see how these are in the same shape? I'm putting them in the same shape to show you that these are like terms. Now, do you see this plus sign right here? Why is that inside the shape? Well, it's inside the shape so that you know that 8y term is positive. It's positive. And so I have 12y and positive 8y. And so I need to add their coefficients. 12 plus 8, that's 20, right? And I keep the variable. What's the variable here? Y. What's the exponent? 1, right? So it's 20y to the first power. But again, if the exponent's 1, you don't need to write it. It's understood to be there. So I've combined 12y and 8y to get 20y. What about these numbers? Positive 12 and negative 10. I'm going to put them in the same shape because they are like terms. They are constants, right? They have no variable. And so you can combine constants. So 12 and negative 10, that's the same thing as 12 minus 10, which would be 2, right? Positive 2. That's why I put a plus sign. It's positive 2. Now, can you add 20y plus 2? Are those like terms? No, they're not, right? Because this has a y in it, and that does not have a y in it. And so that is your simplified expression, 20y plus 2. Next example, I have 8b minus 2 plus b minus 3b. Now here I see parentheses. What number is in front of the parentheses? What number is right there? You may say, Mr. Roper, there is no number there. What are you talking about? There's no number. Well, again, if it's not there, it's invisible. It is there. What is it? You may say 1. Close. It's not 1. There's a negative sign there. So it's negative 1. There is an invisible negative 1 right there. It's right there. And so if you want to go ahead and put it there so you can see it, Go ahead and do that. It's there, but it's invisible. And so I know I'm going to need to distribute that negative 1. And so what do I do with this 8b term? I bring it down. So 8b. Then I have negative 1 times this term. So what's negative 1 times 2? That is negative 2. So I'm going to put a minus 2. I not only distribute to this term, but also to this term. So what's negative 1 rainbow b? Negative 1 times b, that is negative b. Do I distribute to this negative 3b term? No, I don't, right? It's outside the parentheses. So I'm just going to bring it down, minus 3b, okay? Now I've eliminated the parentheses. What I'm going to do now is look for like terms. Do I have terms that are like? Yes, I do, right? I have 8b. I'm going to start off using boxes. I have negative b. Don't forget to put the sign inside the shape. And this is negative 3b. So I have 8b, negative 3b. They all have the same variable, b, and the same exponent, 1. So what's 8b minus b? Well, that would be 7b. What's 7b minus 3b? That would be 4b. What about this negative 2? Are there any other constants to combine it with? No, there's not. So it gets brought down into my simplified expression. So 4b minus 2 is my simplified expression. What number did we distribute? We distributed a negative 1. A negative 1. Okay, numbers 5 and 6, again, you're asked to simplify the expression. Here we have no parentheses, so we don't need to distribute to eliminate the parentheses. We're just going to combine like terms. Okay, so here I see a negative 4x squared. So this is an x squared term. Do you see any other x squared terms? Yes, I do, right? I see this one. So I'm going to put these in the same shape. I'm going to use boxes first. Negative 4x squared. And would this be a positive or negative term? How do I know? Well, that minus sign, right? That's a negative 10x squared. So I need to combine these things. I need to add them together. Now, aren't they both negative terms? This is negative 4x squared. This is negative 10x squared. So if I add their coefficients, don't they have the same sign? Yeah, they have the same sign, right? So I know same signs, add, and keep the sign. So what is 4 plus 10? That would be 14, right? So I added them together. Then I got to keep the sign. So negative 4 plus negative 10, that's negative 14. But I know that when you combine like terms, not only do you add their coefficients, you have to keep the variable, which is x, and you have to keep the exponent, which here is 2. So this is negative 14x squared. Don't forget your variable, don't forget your exponent. Now, I have no x to the first terms, but I do have these constants. I have 15 and negative 7. So what's 15 minus 7? That is positive, so I'll put a plus sign, positive 8. This is my simplified expression, negative 14x squared plus 8. I can't add those. This has an x squared, that has no x or a squared. So negative 14x squared plus 8 is my simplified expression. Number 6, look for the like terms. There are no parentheses, so I don't need to eliminate them by the distributive property. I do need to combine like terms. Here I have a negative x, I would say negative x cubed, right? Because when the exponent is 3, we can say cubed. Are there any other x cubed terms? Right here, right? Isn't this a positive 2x cubed? So I'm going to put it in the same shape. Put them both in boxes, and let's add their coefficients. What's the coefficient here? What number is in front of x cubed? Again, you may say, Mr. Roper, there is no number in front of x cubed. You would be wrong though, right? There's a negative 1 there. It's invisible. So here I have negative 1. Here I have positive 2. So don't those have different signs? I would say different signs, subtract, keep the big guy. Big guy will be positive, so this would be positive 1, or just 1x cubed, 1x cubed. So I can leave the 1 off, but it's understood to be there. So negative x cubed plus 2x cubed is x cubed. You keep the variable, keep the exponent. Next I have negative 2x and positive x. Those are like terms because they have the same variable x, same exponent 1. So what's negative 2 plus 1? That's negative 1, or just negative x. That's your simplified expression. Okay, these last two you're going to evaluate. When you evaluate an expression, you're finding the value of that expression given the value of the variable. And so here we want to evaluate when n equals negative 2. So what we're going to do here is take negative 2 and plug it in right there. Whenever you plug it in, you put it in parentheses. So 4n, what does that mean? 4n means 4 times n, right? That's multiplication. So I have 4 times n, which is negative 2, 4 times n, minus 3, right? It says minus 3. Now, I have to use order of operations here. I can't subtract before I multiply, right? PEMDAS, please excuse my dear Aunt Sally. I have to multiply this first. I have to do that first because it's multiplication. What's 4 times negative 2? That's negative 8. I still need to subtract 3. So here I have negative 8 minus 3. Aren't these same sign? They're both negative. So I would add and keep the sign. So negative 11. Number 8, evaluate when n equals negative 9. This is 36 over n. Now, what does this fraction bar mean? Doesn't that fraction bar mean division? Yeah, right? So I have 36 divided by n, which is this. Okay, then I'm going to subtract 6. What is 36 divided by negative 9? Isn't that negative 4? Yep, different signs. Not subtract, right, because I'm dividing. So I would say different signs negative, right? So I have negative 4 minus 6. Again, this is negative, so same signs add, keep the sign. Negative 10 would be the value of this expression when n equals negative 9.